Welcome to ClickMyProject.com. Now we are going to discuss about the project performance analysis of OPM based channel estimation in mobile OFDM system. Now we are going to discuss about the abstract of this project. In this project, first we analyze the performance of orthogonal matching pursuit algorithm, which is based on compressed channel estimation with deterministic pilot patterns. Then we propose a mathematical framework by defining four normalized mean square errors. First, the total normalized mean square error, the dominant channel components normalized mean square error, and lost error normalized mean square error, then false sum normalized mean square error. The proposed framework provides a useful tool for adaptively optimizing pilot parameters according to rapidly time-varying channel condition when using OMP algorithm-based compressed channel estimation in mobile OFDM system. We believe that the proposed framework provides a useful tool for adaptively optimizing pilot parameters according to rapidly time-varying channel conditions when using OMP-based channel estimation in mobile OFDM system. In this project, performance evaluation is given for all the four normalized mean square errors, and the BR performance is also calculated. Now we are going to discuss about the flow diagram of this project. In this, the first block is OFDM transmitter, in which we will generate the data. The modulation index of QAM is 4, so we have generated the 4 datas, and then we are doing modulation, that is QAM modulation is performed, then adding of cyclic prefix, that is if we add cyclic prefix, the datas are secured, and then pilot insertion. Through pilot insertion, the datas are more in number, and so that we can get a better performance. Then channel estimation. In this project, there are two types of channel estimation used: the sparse channel estimation and channel estimation with normalized mean square error. Before performing this channel estimation, the output we get from OFDM transmitted system, we are doing OMPM algorithm. That is, the OMP algorithm is one of the most important algorithm in this project. So we perform OMP algorithm for the output of transmitted system. Then the output of OMP algorithm is given to channel estimation, in which the NMSE channel estimation, which is of 4 types, that is NMSE false sum, NMSE lost sum, NMSE dominant channel component, NMSE total. These are calculated. After that, the OFDM receiver system, in which the removal of cyclic prefix is done and the removal of pilot insertion. While removing the pilot insertion, the output, which is more in number, will get reduced to our generated data, that is 4. Then QAM demodulation is performed. After performing all these, the performance evaluation has been calculated. In performance evaluation, the graph is plotted for NMSE false sum, NMSE lost sum, NMSE dominant channel component, and NMSE DUB, which is NMSE dominant upper bound. By using these 4, we plot the graph with EB by N0, and then the BRE calculation is done with EB by N0. Then the Q analysis, which is the probability. We find out the probability of lost errors, the probability of success, and the probability of loss. This was the flow of this project. Now we are going to see the running procedure of this project. The coding is done in Matlab 2017B version. The coding is in main file. Now I am going to run this. The coding is in running. It will take a few minutes to display of graph. The graph has been displayed. Wait, the figure 1. This is figure 1. In this figure 1, this is figure 1. This is NMSE DUDB, which is plotted EBN0 and NMSE. There are 3 graphs, that is, it is differentiated with speed. That is, the speed is 90 km, 120 and 150 km. That's all. Then the second graph is, it is also NMSE with speed 120 km. that is EB0 dB and NMSE. There are 4 plots, that is NMSE D dominant, NMSE lost term, NMSE false and NMSE total. These 4 are plotted. The speed for all these graphs are constant 120 km, and these graph are calculated using a formula. Then the same graph is plotted with the speed of 30 km, 30 km, that is NMSE D, NMSEL and NMSE NMSE. By comparing both the graph, we know that 30 km speed with 30 km is lesser, and these are plotted between NMSE and EB0 dB. Then the fourth graph is BER calculation. The BER is calculated for 3 different speeds, which is 90, 120 and 150. That is, the BER is decreasing in order. The graph is plotted between BER and EB0. 3 BER are calculated with respect to speed. The final is the probability. The probability of success, probability of lost error and probability of false arm has been found in this, which is probability, and EB0 dB has been plotted. In this is decreasing in order. That's all about the running procedure of the product.